let's do the two loan scenarios. I'm just going to fill out this table completely, even though you don't need it all for the first problem. But Ronald makes $15 an hour, works 40 hours a week for 50 weeks a year, so he's going to make 15 times 40 times 50. He's going to make $30,000 a year, gross. And if we divide that by 12, that means his gross monthly is $2,500. What's his net annual income? Well, his deductions are 15%. So if he's making $30,000 and he's deducting 15%, he gets to keep 15 from 100 is 85%. So he gets a net annual income of $25,500, and so his net monthly would be that divided by 12, which is $2,125. Okay, so according to the loan sheet that I gave you, he can borrow up to 20% of the net annual loans. 20% of the net annual. So 20% of 0.2 times net annual is $25,500. So I can borrow a total of $5,100. That much in loans. 10% of the net monthly can be the payments. So 10% of this would be $212.50. That's how much he can afford in payments. If he was going to take out a mortgage, that's 30%, according to that sheet, of the gross monthly. So 2,500 times 0.3 is 750. You could have mixed mortgage payments of $750. Now you don't need that for this problem because he said he just purchased a $1,000 flat screen. And he needs to borrow for a car. And he's making monthly payments of 12% for 1 year. So let's see how much his payments are. So we use the payment formula. So pull out your sheet, look at that one. And that would be the principal times the APR, 0.12 divided by 12, close parenthesis, divided by, open parenthesis, 1 minus, open parenthesis, 1 plus the APR, 0.12 divided by 12, close parenthesis, to the, open parenthesis, negative 12 times the number of years, 1 year, close parenthesis, and then close parenthesis, and the, 2. Oh, I forgot to start my denominator with a parenthesis. I hit a 1 instead of a parenthesis there. 1 minus 1 plus. Okay, there we go. So the payment on this flat screen is $88.85. So how much can he afford in payments on his car. Can be his total payments can be $212.50 minus the 88.85, which is $123.65. He can afford that much of a car payment. And how much can he borrow on the car? Well, his total payments can be $5,100 minus how much he has already borrowed, which is $1,000. So he can only borrow $4,100 on a car, and can only pay up to $123 on payments. Okay. So that was Project 3, the first question. And the second question is about a mortgage, and their annual gross is $80,000, and we really don't need the monthly and all these because these are all for loans, and we're just working on a mortgage here. So the gross monthly is 80,000 divided by 12, which is 6,666 and 67 cents. And the mortgage payment can be 30% of the gross monthly, which is $2,000. So the payments can be $2,000 on their mortgage. So we don't need the deductions. We don't need the monthly income. We can get that from all that. We can figure out all this, but we don't need it for the mortgage. And then I did it on the last one, so I don't need to do that. Determine the total cost would be maximum payment for a 15-year at 3.5%, or a 30-year at 30-year was at 4%. Okay. So now we have to figure out how much the payment would be. So I need to look back here and figure out how big the loan can be based on the payment. So that's just this stuff turned upside down with and no P. And we got to get the payment, and then we're going to find out the P. So the payment is 2,000 times, let's see, parenthesis, 1 minus the 1 plus, okay. 1 minus parenthesis 1 plus the APR, which is 3 on the 15-year is 3.5.035 divided by 12. Close parenthesis to the parenthesis negative 12 times 15 years. Close parenthesis divided by parenthesis 0.035 divided by 12. And I believe that's the correct formula. Let me take a quick look at it. Yeah, I think that'll get me the amount of the loan. So a 15-year loan can be $279,766 ish, 24 cents. We can round it off to just the total amount of the loan. Okay, so that's how big a loan they can do. The other thing they said, then determine what the total cost would be. So that's $2,000 times 12 times a year times 15 years. The total cost will be times 12 times 15, which is $360,000. So that's quite a bit more than what we borrowed. 275, 360, that's $100,000 more that we're going to have to pay back. But the house, the value of the house and the part that we're loaning on is going to increase at 1.5% per year. So we're going to use this formula to see how much that house is worth. So that formula says 279,766 times 1 plus the APR, and the homes are going up at 0.015, and we're making monthly payments, so we can just go 12 times, we're doing this for 15 years, or we could do 1 and 1. Both of those would be close. They said 1.5% per year, so I'm just going to use 1 and 1. So I just need to take it to the 15. So we got 279,766 times 1 plus 0.015, close parenthesis, to the 15. So the value of the house goes up to 349,772. So the house is almost worth how much we put into it, and we didn't have to pay rent on another place. Now we might be paying a little bit more than the rent would have been, but $2,000 could be what the rent could be in some place. But you have all the value of the house now is yours. You own this in the 15 years. And that's something you didn't have before. So it makes sense to make the loan. Now we're supposed to do the same thing for a 30-year at 4%. So the payments would be a little different here. So we got to go back where we figured out the payment, and now it's 4% for 30 years. 4%, and we're still can make payments of $2,000. So now we can take out a loan of $418,048, but that's close enough. So we can buy more of a house. This is going to be paying longer. We're going to be paying 2,000 times 12 times 30. We're going to pay 720,000. But how much will the house be worth? So we have 418,922 parenthesis 1 plus 0.04 to the 30 years. Oop. To 30 years. And we get the value. Did I get all that in there? $418,122, 1 plus 0.0. Oh no, wait a minute. The house values are going up 0.15. That's what I did wrong. If they went up at the same interest rate, the house would be worth $1 million, which is pretty cool, but not what it would be. It's only going up at 0.1 insert 5, 1.5%. So the house would be worth $654,808, which is, 65,000 less than you put into it. So you chalk up 65,000 towards your rent, and the rest of it's money you save because that's the value of the house now. You've got that equity. So that's project